Note for Mr. Schroeder. I've been thinking about the robot. Let's assume, 1, that we'll locate the problem in the production unit. 2, that a component will need to be replaced. I think we should ask ESOC to run a simulation of all replacement procedures. It looks as if my idea is going to be put to the test. Correction, it looks as if your idea is going to be. Our idea?
Well, that's the way you wanted it. If you want almost every system to be duplicated, it's sure to be large and complex.
Look, Wilhelm, I know it's not ideal, but if a breakdown does occur, then at least we can rely on the redundant system to take over.
And what if that breaks down? Are you saying you want a second redundant system?
I guess I am.
Not if I can help it, Stan. Look, as far as I'm concerned, it's getting much too complex. Look, what we're trying to do is pump solutions through the electrophoresis unit, collect the products, and return the buffer. Cut the redundant circuit, please. Basically, that's what we need. 1 circuit.
Right. But if one component fails, then the whole operation fails.
I suppose we standardize our components as far as possible to keep the number of different types to a minimum.
So?
Well, we keep several of each type in store. If one of the components breaks down, we replace it from store just as we would on Earth.
Are you crazy? How can you replace components in space? Are you going out there yourself?
There's no need to. Sam would do it.
Sam? Who the heck is Sam?
Here we are testing the manipulator.
Manipulator.
It is a 6-axis manipulator.
6 axis?
Yeah, we will show you. Danke, Hagon.
It rotates there at the waist, and it bends there at the shoulder.
Also here and here.
The elbow and the wrist.
That's 4 axes. The claw
Rotates. It also opens and closes. So, you see, we have a 6-axis manipulator. S-A-M.
Sam.
Can you operate it manually as well?
manually.
Or can you move it by hand? For instance, can the operator make it give you something?
Ah, yes, yes. Bitte, gib es Herrn Schröder.
Now, if the manipulator were fitted with a mini TV camera, an operator on Earth could use it for making repairs in space. For instance, it could remove defective components, pick replacements from the store, put them in place, and so on.
But you're always complaining about the size and weight of the unit. Surely you don't intend to put a thing like that inside it.
No, not quite that big. Herr Berg, could you show us your designs for the smaller version?
Ah, please. Now, this one is only 2 meters high.
Sam Jr.
We do not give robots names like that. They are not human. They are only stupid machines. We call this one R10.
I see.
It's very flexible, Stan. Put it in the middle of the production unit, it'll reach every part of it.
Wilhelm, why on earth didn't you mention this idea earlier?
Oh, I wanted to satisfy myself that it was a serious option before I asked your opinion.
How thoroughly has it been tested?
Tested?
Yeah.
Well, in 3 months' time, we will have a first model.
Prototype.
You mean you haven't even built one yet?
Oh, we don't need it yet. Plenty of time to have it built and tested.
But we have to design the unit right now. What if Sam Jr. doesn't pass his exams? I mean, what if R10 fails the tests? It'll be too late then to go back to the drawing board.
The technology we use has been tested for many years. Allow me, I will show you.
No, I really have to.
Stan, please.
Oh. Okay.
The first time people used automation was for weaving cloth. It was a system of Lockkarten?
Punched cards.
That was around the year 1730. The most traditional automation is for one process only, understand? Machines make 1, 2, 3 movements, perhaps, again and again. But the manipulators we make have many, many possibilities.
You mean that they can move in all directions, that they can be reprogrammed for many different tasks? That's what we need. Flexibility.
And here is a remote-controlled manipulator used for underwater maintenance inside nuclear reactors.
Okay. I've seen enough. Thank you. Can a machine like this really be programmed with sufficient accuracy to replace tubes or whatever?
No, certainly. Tomorrow, I will arrange for you to go to a laboratory where they are doing research on the robot control.
If you insist.
Hallo, Liebling. Hattest du einen guten Tag?
English, Margaret. Please, always English.
I think that's the only reason you married an English girl, to learn the language.
Thank you. I need this.
Bad day?
Yes. I had some important visitors today, including an American. Very difficult.
The language or the American?
Both.
What did they want?
Oh, they're thinking of using our new manipulators in space.
In space? Oh, that's wonderful. I mean, think of the publicity.
Of course, but the American is beunruhigt.
Worried, anxious.
Yes, worried because it hasn't been built yet. We shall see.
Well, I had a problem today, too. The washing machine wouldn't switch to spin at the end of the cycle. I had to call the engineer.
But it's a brand new machine. It's the most recent design.
Oh, the engineer said that new models often have teething troubles.
Teething troubles?
Things that go wrong when a product is new.
Ah. Perhaps that is what was worrying the American, eh?
I'm sure your machine will work, darling.
Yeah.
Now, this is our assembly room where we assemble the prototypes before sending them out to the factories. Well, for instance, here is an assembly line which we are developing for misers. As you see, there are various components which must be presented to the manipulators in the right sequence. The success of the line depends a great deal upon the design of the equipment which supplies the components. We call it the peripheral equipment. For instance, when small components like this are removed from the storage bin, they must be facing the same way, in the same configuration. Then they are delivered to the assembly line. Now, this is our answer to the most difficult challenge in robotics, the bin picking problem. How to make a robot pick out components that are lying on top of one another. We have a monitor here so we can see what is happening. Now, the camera provides a picture for the computer. The computer then converts the picture into a diagram. It is marking out the critical points on the components in the bin. On that basis, it calculates which component is on the top and then aligns the manipulator over it to pick it out. Yeah?
Aha. Excellent. Fortunately, our problem is much less complicated.
Is it?
Of course. The design of our production unit is fixed. We can program the robot to reach every part of it. We can arrange the redundant components in store so that the robot will pick them out. It will be quite capable of fitting them, as you see.
Well, maybe it is possible.
Our designers have made this model of your production unit. If the manipulator is attached to the bottom plate here, every part of the unit is within its space of movement.
Sphere of operation.
Yes. And here are the specifications of the manipulator which we propose for you. The weight has been reduced by the use of lightweight materials. I have checked that they are okay for space.
The idea is interesting, I admit that, but isn't it all too risky?
Because the robot is untested?
The whole concept is untested. No one has ever sent up a spacecraft before without redundant systems. This idea of putting a monkey on board.
Monkey?
The robot. I'm trying to work out if we'll save weight. If we do, then... I just put a new battery in this the other day. The same component can fail again and again. With a conventional redundant system, we could do nothing about it, but with a system which could replace the same component as often as necessary. Maybe Sam is the answer.
Well, that is what we've been...
We standardize our components as far as possible and carry a load of spares. It's a whole new concept of redundancy. And we'll be the first to use it. Well, Wilhelm, what do you think of my idea?
You've persuaded me.
You persuaded me. Well, Sam Jr., if we need you, I hope you don't let us down.